more examples of working with vectors. So we have this initial and terminal point of 2, -1, and 1, negative, or -1, 3. And let's just go ahead and sketch that in its given position. Okay, so we have 2 and -1. So this is our initial point. And then we have -1 and then 3. So this is the terminal point. Okay, and so our vector is going to look something like that. Okay. Now, if we want to put it into the component form, okay, I'll just call it U. That's going to be terminal minus initial. Okay, so that's -1 minus 2, terminal minus initial. So 3 minus a minus 1. Or in other words, that would be -3, comma 4. Now, I could go ahead and plot that vector, okay, and we want to plot that from the origin, okay, so that's going to be -3, 4, and that would be the terminal point up here. The initial point would be the origin, and so that's what this vector looks like. And again, these two vectors are equal because they have the same direction and the same magnitude. Now, to compute the magnitude, all we're going to do is just take the square roots of those two values, okay? And we're going to square those, okay? So we just plug it right into the distance formula, essentially. So that's going to be the square root of -1 minus 2 squared plus 3 minus a minus 1 squared. This one's really easy. That works out to be 3 squared, which is 9. That works out to be 4 squared, which is going to be 16. That's a 1, by the way. So 3 minus a minus 1. Square root of 25 is 5, right? Another way we could have done this is just take these values, square them, and take the square root, okay? So an alternative way, and this is actually a little bit easier, is you just take the square root of -3 square plus 4 square. And remember, these two have the same magnitude, so that might be a little bit easier. So 9 plus 16 equals root 25, which is 5. Okay, so either way you want to do it, they're both just about as easy because they're just computational, but just showing you that that might be a little bit easier way to do it rather than going through and using the two non-zero values. All right, one last example of this. So we have the point 1, 3 and terminal point -8, 9. All right, so I'm going to need a little bit more room this time, but that's okay. So we have 1, 3. So right here is going to be our initial point, and the terminal is -8, and then -9. Okay, so somewhere down here, I know this Cartesian plane is not to scale. All right, but all right, and then that is our vector. All right, now let's go ahead. I'm going to call it U, okay, and that's going to be -8 minus 1, -9 minus 3, or in other words, that's going to be -9 minus 12. Okay, so that's going to be -9, comma, -12, and that's going to be the component form. Okay, all right. Now we want to try to find the magnitude of U. Right? And that's actually pretty easy because now I can just use these two values, square them. So -9 squared plus -12 squared, right? We just throw that in our calculator. Okay, so we would have the square root of -9 squared plus 12 squared. And it, well, it should be -12 squared, excuse me. So back that up. 12 squared. All right, now it doesn't give us an exact answer. Okay, square. All right, oh, it does. Well, I put the square on the outside. That doesn't help. All right, so let's try to put that on the inside. All right, and then it doesn't like this. Okay, so it ends up being 15. It does give us a nice value out of that. Okay, so the magnitude is going to be 15. And if I wanted to plot this in standard position, I would just go 9 to the left and then 12 down. Okay, so remember this was 8, 1 more is 9, and then we had 9 down. And so we're going to have 10, 11, 12. And so our point should be like right about here. All right. And I know this is going to be precisely parallel. Those two vectors should be, all right, but that should be the vector in the standard form here. Okay. All right. Now, let's talk about really quickly about vector addition and scalar multiplication. Okay, these are really basic operations, and they're actually pretty easy. Vector addition, all we do is we just add the first components together, and we add the second components together to form a new vector. Right? A scalar, basically, we're going to multiply by some number, and that's going to change the magnitude of the vector. Right? So essentially, if we wanted to add vector u to vector v, we would add the x components or the x directions, and we would add the y directions together. So it's actually really easy to do that. Scalar multiplication, we just multiplied both of the components by whatever the value is. All right, so let me show you how easy this is. If I have that u is 3, 1 and v is negative 1, 4, 2u is going to be 2 times 3 comma 1, which is going to be 6 comma 2. Okay, so that's going to be by distributing this through. Okay, so that's literally how easy it is. Okay. U minus v is going to be 3 comma 1 minus negative 1 comma 4. So just taking u minus v. So 3 minus a minus 1 is 4. 1 minus 4 is negative 3. And that's all we have to do with it. Okay, so nice and easy. 3v plus 2u. Okay, so we're going to have 3 times negative 1, 4 plus 2 times 3, 1. We're going to multiply the scalar first. Okay, so that's going to be negative 3 comma 12 plus 6 comma 2. And now we're just going to add. Okay, so we have negative 3 plus 6 is going to be 3. 12 plus 2 is going to be 14. Okay, so that's literally all we have to do with this. Finally, negative 4u minus 3v, we're going to have negative 4 times u, which was 3 comma 1, minus 3 times the quantity of v, which was negative 1, 4. And so, distributing negative 4 and 3, okay, we're going to end up with negative 12, negative 4, minus negative 3 comma 12. And then if we subtract negative 12 minus a minus 3 is going to be negative 9. Negative 4 minus 12 is going to be a negative 16. Okay, so that's all we have to do with vector addition and subtraction and scalar multiplication. Really, really basic. Okay, so, but we have to master those fundamental sorts of operations before we go on to our next operations. Okay, so we're going to take a look at some properties of vectors in our next video, and then we're going to start taking a look at a different way to write vectors as a linear combination.